Good day, everyone. Welcome to another video learning with Bahagharing Lexi. In our previous video lesson, you learned how to find possible values and compute probabilities corresponding to a given random variable presented in a graph and in a probability distribution. In this video, we are going to study the measure of central tendency, which will help us interpret the mean of the probability distribution. And for today's topic, we are going to talk about mean of discrete random variables. And to start with, let us first go with our objectives for this video learning. And at the end of the video, you are expected to illustrate the mean of discrete random variables, calculate the mean of discrete random variable, and solve problems related to mean and interpret the result. Now, to start with our video learning discussion, first we are going to explore, okay? And I do have here a situation wherein there are 4 tiles. Suppose 4 tiles numbered 1, 2, 3, and 4 are on in the jar. I repeat, there are 4 tiles, and these 4 tiles are numbered 1, 2, 3, and 4, and in place in a jar. Okay. A tile is picked and returned in the jar 15 times, meaning to say, although we do have 4 tiles, the 4 tiles will be picked and we are going to pick 15 times, okay? And the result are as follows. Now, for tile 1, the number of times the tile 1 was picked is 2. Then, for tile 2, we do have 4, meaning to say tile 2 was picked 4 times. For tile 3, 8 times. And for tile 4, we have 1 time. Okay? Therefore, the number of times the given tile or tiles were picked is 15 times. Okay? Therefore, in this case, we are asked to, what if we are asked to find for the average, okay? The average corresponding to the tiles being picked, okay? I repeat, we do have tile 1 twice or 2 times. Tile 2, we have 4 times. Tile 3, we have 8 times. And tile 4, we have once, okay? Now, in this case, what is the average number picked in the given situation? Okay. Now, we know that if we are going to get the average, we are just going to get the sum, okay? But in this case, we do have what we call the frequency, okay? Hence, we are going to multiply tile 1 by 2 because tile 1 was picked 2 times, plus we have tile 2 times 4 because tile 2 was picked 4 times, plus we have tile 3 and tile 3 was picked 8 times. Therefore, we have to multiply 3 times 8. And last one, we have tile 4 and it was picked once. Therefore, we are going to multiply 4 times 1. And remember, to get the average, we have to divide the sum, okay, the sum of the product by 15 because we pick the tiles 15 times. Okay, therefore, our divisor here will be equal to 15. Okay, and then we are going to multiply 1 times 2, 2 times 4, 3 times 8, 4 times 1. Okay. Now, 1 times 2 is 2. 2 times 4 is 8. 3 times 4 is 24. And 4 times 1 is 4. And whatever be the product, we are going to get the sum. And our sum is 38. Okay. Then, from the given sum of the product, therefore, we are going to divide it by 15. Therefore, our average will be equal to 20, or our average is equal to 2.53. I repeat, relative to the given, okay, as to the average number peak in the given situation, our answer is equal to 2.53. Now, how did we able to obtain that average number peak corresponding to the tile? Then what we did was we just multiply tile 1 times 2, tile 2 times 4, 3 times 8, that is tile number 3 multiplied by 8, and then tile 4, we do have multiply it to 1 divided by the number of how many times we pick the given tiles in the jar. Okay, therefore the answer will be 2.53. What if we are asked the same, okay, the same value? What if we are asked to find for the average and the only given are the random variables and its corresponding probability? Okay, how are we going to find for the average? Now, in this example that we have, we are going to um, translate this one into a probability distribution, okay, or discrete probability distribution. Okay, now let me show you how the given distribution was changed and transformed into a probability distribution, to be exact, discrete probability distribution. Now remember, in this concept, we do have tiles now labeled as or numbered as 1, 2, 3, 4. Now this will represent our random variables. Okay, and then the frequency, we do have 2, 4, 8, and 1. Now, this frequency will be utilized as our outcome all over the total possible outcomes. Okay, the total possible outcomes will be equal to 15. And then since we do have the frequency, therefore, the probability that tile 1 will appear is equal to 2 over 15. Okay, since tile 1 was appeared twice, therefore we are going to write our n for the numerator as 2, and the total number of peak is equal to 15. Therefore, the probability that random variable or tiled 1 will appear is equal to 2 over 15. And then for tile 2, we do have 4 over 15. We do have the frequency 4 all over the total, okay, which is 15. Now for tile 3, we do have 8 over 15. And for tile 4, we do have 1 over 15. Now, these are what we call the probabilities corresponding to each random variable. Okay? Therefore, from this case, how are we going to get the average without applying the concept of the previous operation that we made? Now, in this case, what I am going to do is just to multiply the random variable from its corresponding or to its corresponding probability. Therefore, I do have 1 times 2 over 15. That is random variable 1 or tilde 1 multiplied to its corresponding probability, that is 2 over 15. Plus, we have tilde 2 or random variable 2 multiply to 4 over 15, which is the corresponding probability of the random variable 2. Next, we do have 3 times 8 over 15. And the last one will be 4 times 1 over 15. Okay? And then, after that, you have to get the product, okay? And that will become 2 over 15, 1 times 2, all over 15, plus 8 over 15, that is 2 times 4, all over 15. Then 3 times 8, 24, all over 15. And last one, 4 over 15. And since we do have similar fraction or similar fractions, we're just going to get the numerator, the sum of the numerator, which is equal to 38 over 15. Remember, in our previous manner of finding the average, we arrive with 38 over 15, wherein our average here is 2.53. And same manner, we arrive with the average of the given distribution, but this time we find the average of the given discrete probability distribution. Okay, now how did we able to get the average of discrete probability distribution or discrete random variables? Okay, now in this case, we just multiply the given random variable times its corresponding probability. And then after that, we get the sum of the product. And whatever be the sum of the product, that will become the average or expected value of the given discrete random variable probability or discrete probability distribution. Okay, now what is mean of discrete random variables or mean of discrete probability distribution? Now, when we talk about mean of discrete random variable or variables, the mean of discrete random variables, also known as expected value, remember, if you are being asked to get the mean or expected value, that is just the same. Okay, same concept that is being asked. Now, it is the weighted average of all possible values of the random variables. I repeat, when we talk about mean of discrete random variables, also known as expected value, that is the weighted average of all possible values of the random variables. Now, we do have all possible values of the random variable relative to the weighted average. Okay? Therefore, that is what we call the expected value or what we call the mean. Okay? Now, we made use of the symbol mu, mu. Okay, this one. Now, this is the symbol that we are going to use when we are writing and when we are illustrating the expected value of the given discrete random variable. We do have the mu, mu. And that is if the probability of every value of x is written as this one. Okay, P serve as the probability of the given random variable is equal to, okay, whatever be the random variable that we are dealing with. Therefore, the expected value or the mean of discrete random variable is equated as the summation of the product between the random variable multiply to its corresponding probability. Meaning to say, you have to get first the product of the given random variable and its corresponding probability. After getting the product, then you are going to get the sum. And whatever be the sum, that is what we call the expected value, or what we call the mean of discrete random variable. That's why it is what we call the weighted average, because we are getting the product of the given random variable and its corresponding probability. And to illustrate this one, let me show my example number 1. Determine the expected value of the correct scores. Suppose there is an examination, and after the examination, your paper was checked. Therefore, we are looking for the correct responses. And here is our probability distribution. Okay. Now, for correct scores, we do have 18, 21, 22, 24, 27. These will also serve as our random variables because we are talking about correct scores, okay, obtained in a certain examination. And then the probability of each random variables are the following: 0.10 for 18, 0.24 for 21, 0.31 for 22, 0.20 for 24, and 0.15 for 27. I repeat, the probability for correct scores: 18, we have 10% or 0.10. For 21, we have 0.24. For 22, we have 0.31. For 24, we do have 0.20. And for 27, we have 0.15. Okay, now the sum of the given probability will always be equal to 1 or 100%. Okay, now in this case, we are going to utilize the given formula because we are looking for the expected value or the mean. And we have the mu is equal to, now you have to get the product, plus we have 21 times 0.24, plus we have 22 times 0.31, plus 24 times 0.20, plus 24 times 0.20. Okay, we have 22.31 yen. And last one, we have 27 times 0.05. I repeat, 18 times 0.10, 21 times 0.24, 22 times 0.31, 24 times 0.20, and 27 times 0.15. Then after that, after you get the product, okay, then you have to get the sum. We do have 1.80, 5.04, 6.82, 4.80, 4.05. Okay. And then after that, you have to get the sum. And the sum will be 22.51. Meaning to say, the expected value of the correct scores, or the average or the mean of the given discrete random variables, is equal to 22.51. Okay, I hope you're able to get the correct answer, or you're able to take down some procedural concept as to we are dealing with our illustrative example number 1. Okay, now for this, our answer is equal to 22.51. Okay, now let us proceed with another illustrative example. We go with illustrative example number 2. Okay, now in this case, let me read the problem or the situation. We do have the report of a weather bureau on the forecast of the number of typhoons entering the country's area of responsibility is manifested in the following probability distribution. Now, in this problem, we are dealing with the forecast on the number of typhoons entering the Philippine responsibility. Now, there is a chance that there is no weather to enter or no typhoon to enter, rather, not the weather, but it's the typhoon. Now, there is also a chance that in a certain month there is one typhoon. There is also a chance that there are two, three, or four. Okay. Now, let me show you the given probability distribution as to the number of typhoon entering the Philippine responsibility per month. There is a case that there is zero typhoon. There is one typhoon. We do have two typhoons, three or four. And the corresponding probability are the following. For zero typhoon, we have 0.15. For one typhoon, we have 0.35. For two typhoons, we do have 0.30. For three typhoons, we do have 0.10. And for four typhoons, we do have 0.10. Okay? Therefore, what if we are going to get the expected, okay, the expected value or the mean corresponding to the typhoons that entering the country's area of responsibility? Okay, going back with our illustrative example number 2. Now we do have here our discrete probability distribution. And from this probability distribution, now our question is, what is the expected value? And to get our expected value relative to the number of typhoons that are going to enter the area of responsibility, now we do have mu, or the expected value, is equal to, we have 0 times 0.15, that is the random variable 0 and its corresponding probability, plus we have 1 times 0.35 plus 2 times 0.30 plus 3 times 0.10. And last one, we do have 4 times 0.10. Then after that, we are going to get the product, okay? And for number 1, we have 0. Number 2, we have 0.35. For number 3, we do have 0.60. And we have, for number 4, we have 0.30. And last one, we do have 0.40. Then after that, we have to get our summation. Okay, therefore, the answer is 1.65. Okay, therefore, the expected value of the given probability distribution relative to the number of typhoons that is expected to enter the country's area of responsibility is approximately equal to 2. Okay, because as to the number of typhoons, it is countable. It can be 0, 1, 2, 3, or 4. Therefore, the average is 1.65, but that can be expressed as 2 since we are dealing with the number of typhoons. Since we don't have half typhoon, that it's always countable, okay? But for this concept, we able to get our expected value because we get the weighted average, okay, of the given random variable and its expected probability. Hence, our expected value as to the number of typhoons is equal to 1.65. Okay? Okay, for further example and enhancement of our learning as regards to the expected value or the mean of the given discrete random variables. Now let us proceed with another example. This is illustrative example number 3. Okay, now let me read the problem. We have the probability of earnings for a projected profit for 5 months of online business is presented below, because nowadays it is really um, or more of the given business nowadays do use or do engage in online business. Okay. Now, in this case, here is the given projected profit or the average projected profit for the given 5 months of online business. Okay. I repeat, the probability of earnings for a projected profit for 5 months of online business is presented below. Solve the average projected profit. Here is our distribution. Now, as you can see, we do have 20, 15, 18, 35, and 12. Now, the total sum here is equal to 100. Therefore, it can be expressed into decimal. This will become 0.20, 0.15, 0.18, 0.35, 0.12. Or if you want, you can have 20 over 100 since the sum here is equal to 100. Okay? Therefore, how are we going to get the expected average of profit? Okay? Now we do have first, we have 56 and its corresponding probability. We have 0.20, and then we have 77 times 0.15. Next, 82 times 0.18. Next, 63 times 0.35. And last one, we do have 100 times 0.12. As I said, the sum here is equal to 100. Hence, this is divided into 100. Therefore, we do have 0.20, 0.15, 0.18, 0.35, and 0.12. Okay? Then after that, we have to get the product. Okay, therefore, we have 11.20. Next, we do have 11.15. Next, we have 14.76. 22.05, 12. Okay, therefore, after knowing the product, then we have to get the sum. And the sum will be 71.56. Therefore, the expected projected average profit for 5 months is equal to 71.56. But we have to express this one into thousands. Okay, why? Because in the given random variables as illustrated above, 56, 77, 82, 63, and 100, this was expressed into what? Thousands. Okay, therefore, our answer will be 71,560 pesos as an average projected profit for 5 months in an online business. I repeat, 71,560 pesos. Okay, because 56 originally, 56 was equal to 56,000. 77 into 77,000. Okay, and the rest. That's why in number 3, our answer is equal to 71,560 pesos. Okay? Don't forget to write the monetary symbol for our problem number 3. Okay, now what if in the given illustrative examples 1, 2, 3, we able to get the expected value or the mean of the given discrete random variables? What if we are being asked or we are asked to find for or to interpret the result? Now, in that case, what do we mean by interpretation of mean of discrete random variables? Because there will always be a chance that we are being asked to interpret the obtained value. Now, when we talk about interpretation of mean of discrete random variables, in a random variable, the mean is the average value of all the outcomes. I repeat, the mean or the expected value is the average value of all the outcomes. Okay? The mean of a random variable weighs each outcome represented by x, which is our random variable, according to its probability. Okay? And if the random variable x, okay, is multiplied to a value b, and then there is an increase by a value of a, therefore the mean will be affected in the same manner, meaning to say, if by chance that the obtained value or the expected value or the mean, okay, now there is a chance that the given random variable is increased. Therefore, the average or the expected value of the given discrete random variable will also be affected. But we cannot say directly what will be the effect or how it will be affected, whether there will be an increase of addition or an increase in terms of multiplication. It depends upon the given situation. But always remember that if there is a change, okay, if there is a change, an increase in the given random variable multiplied to its corresponding probability, if there is an increase, therefore the mean will also increase. If there is a decrease, therefore the mean will also decrease. Therefore, how are we going to interpret now the result? Okay. Now, going back with our illustrative example number 2, the report of a weather bureau on the forecast of the number of typhoons entering the country. Now, how are we going to interpret this one so that our reader are going to understand the expected value or the number that we able to compute? Now, we can write our interpretation as this one: the expected number of typhoon that enters the country per month is 1.65. But since we are talking about numbers of countable typhoons, therefore, the expected number of typhoon that enters the country per month is approximately equal to 2 or is equal to 2. Okay, more or less. It can be 1, it can be 2. Okay, but in this case scenario, in our illustrative example, the expected typhoon that will enter the country per month is 2. Okay, then for illustrative example number 3, we do have our mu is equal to 71.56, or the expected value is equal to 71.56. And as I mentioned earlier, 71.56 is just a representation, and we have to multiply it to 1,000. Therefore, the average projected profit for 5 months is 71,560 pesos. Meaning to say, after the online business for 5 months, the average projected profit is equal to 71,560. Now, this is how we interpret the given result or the given mean or expected value of the given discrete random variable. With this, always remember that the mean of discrete random variables, also known as expected value, wherein we are using the mu, is the weighted average of all possible values of the random variable. And this is now the formula, summation of the summation of the product between the random variable and its corresponding probability. Okay, with this, happy learning. I hope you're able to learn something with the mean of discrete random variable and looking forward for another video learning with Bagharing Lexi. And if you do have questions or query, just write down in a comment section.